Okay. And if you recall last class, we started discussing inheritance. So inheritance is to describe the relationship between superclass and the subclass. So subclass inherited certain subclass inherits some properties and methods from superclass. And in UML diagram, we use the angle to represent. So point to is a superclass. Okay, point from is a subclass. So that's regarding inheritance. And we learned a new keyword regarding visibility is protected. So for protected, so it can be accessible in subclass also. So if the property and the method defined as protected accessibility, then it also accessible in subclass, even in different packages. Okay. So that's regarding inheritance. And we also learned another keyword for OOP is polymorphism. Okay, polymorphism, and we discussed a method. Is it the method parameter type is some superclass, and we can plug in. You allow to plug in subclass also. Okay, so this is called polymorphism. Okay, polymorphism. And we also learned dynamic binding. The dynamic binding. Dynamic binding is when you define a variable, is it so a superclass variable, is it? And you assign it to a subclass object, is it? So this is allowed because that represent is a relationship, is allowed. And then later on, when you call some method, and the method in subclass, you have the overridden one. Overriding one, is it? Then what this method will be invoked, and the superclass also has one, is it? So even though the variable type is superclass, but the method going to come from subclass. Okay, so this concept, we call it dynamic binding. Okay, so it's going to bind at runtime when your program is executed. Okay, so that's just a quick review, and let's also do a quick review of our example. So the example is that employee, is it? And we have this commission employee. And we also mentioned in Java, object is the root class of all of the classes. Okay, so whenever you do inheritance, you use a keyword extends. Okay, don't worry about that. We will learn later on. So anyway, the commission employee, it's a subclass of object class. Normally, we don't need to write that. Is it here? It's just explicitly write it. Okay. So commission employee, anyway, here is a class. And we also define some of its instance variable as protected. And it has a number of get and set methods. And we also explained this toString because it provides the override who override objects. Okay, objects. So that, and for this clone, it's also override objects. Okay, object. And to reference to refer the superclass, you call the super, the keyword. Okay, keyword super. And over here, it's just superclass is clone. And this equals method also exists in object. That's how we provide this as override method. And its parameter is what? Is object. Is it object? And object, so because over here we discuss commission employee, so that's why we cast, okay, cast a, so here is cast a super class object, is it to a subclass type, is it? And then later on, you just call subclasses. You can make use of subclasses respective features, is it? So that's how over here we need to cast it, okay? Because otherwise you cannot access the instance variables, okay? So anyway, so we also learned overloading, method overloading versus method overriding. So last class we mentioned that. So you just be careful here. Whenever you do override, you better have this annotation. Okay. So that's this commission employee. And then let's take a look. The base plus commission employee. Then it extends that commission employee. So it's a subclass of commission employee, is it? And for base class, not base class, for subclass is constructor. Constructor cannot override, okay? Super classes. Constructor. You cannot, is it? Generally speaking, in subclass, you first invoke superclasses respective constructor. That's how we do it. So over here, basically to call commission employees constructor, okay? And then you do something else after you invoke superclasses constructor for your own constructor, subclass constructor. And then for this subclass, then it's pretty straightforward, just have some set get method. And then for this earnings method, is it override commission employees earnings method. So this is an override method. And the toString, same thing, is it? This is a next level override commission employees. Is it commission employees? Okay, and also over here, So in subclass, you directly access the name, social security number, etc. And all of this are from superclass. But you can directly access. Why? Because they are protected in superclass. That's why you can directly access. Okay. That's all of the ideas. And then we have the driver, etc. So it's a pretty straightforward. First, commission employee, nothing new. And yeah, we call the clone method, so not a lot of new things. So this is, yeah. And then we call the subclass. We create a subclass method, employee. Then when it invoke the toString, it will invoke the subclasses. And what else? Yeah, that's last class. I remember we already discussed, but let's just do a quick review, okay, about this polymorphism. So if you recall that M is a method, and that M method takes object. The parameter type should be object, but here we plug in commission employee object. And the next one, what we plug in is we plug in base plus commission employee object. So we plug in with different type of object. But both of them are subclass of object. So that's allowed. So this is called polymorphism. Okay. Because that's this method, its parameters. So X is supposed to be object, but what we plug in is commission employee and the base plus commission employee. Okay. And this toString, then when you plug in commission employee object, then it will be the commission employee. So then it involves dynamic binding when it calls the respective method. Okay. So if you plug in commission employee, then to call commission employees toString. If you plug in with base plus commission employee, then over here it will call the base plus commission employee. So polymorphism and dynamic binding over here, they work together. What next one shows us is this commission employee 2, the type, the variable type is commission employee, and this is a subclass object. Is it a base plus? This is base plus. So you assign a subclass to a superclass. Okay, so that is fine. You are allowed to do that. But over here, when you call commission employee to data toString, so this toString will be from base plus commission employee. Okay, so once again, over here, it's dynamic binding. Okay, dynamic binding. And then next, let's see. For this variable, the type is object, then you assign sub to super type. This is allowed. Then you can check, okay, if it is this instance, yeah, you can call it to check. And if it is, then you can cast it, okay. we can also cast superclass type. Is it to a subclass type, and then you can call the respective method. Okay, because if you don't do the cast, if you try to directly access, it won't work. Okay, so you need to cast and then call, because this method only exists in subclass, not like toString. toString, it also exists in superclass. It just needs to pick the right one. Is it? So that's taken care of by dynamic binding. But over here, you need to cast it, and then you will be able to access the subclass's respective method. And what the next one is just to do the equals check. Okay, and we already discussed quite a number of times. Okay, the dot equals method and the equal. So this is for reference check. So basic must be the same object. Is it? And this not necessary to be the same object. So this is 1 and this is 2. Is it? Not necessary be the same. So this just contents the same. The same content, then this is true. Okay. And so basically this example, we already completed. So a quick review, okay. And what next one today we will discuss is, find it, is this, where is my, hold on, okay, let me find, it is this one, find the, no, not this one. Why I cannot find that specific screen to share? Okay, I found it. Okay, so today we will have another new concept. We will see that in our example, it's about a Java class called ArrayList. In the beginning of the class, we learned array. Is it? Array, the size is fixed. During declaration. The declaration, and then you cannot change it. That for array list, so it provides more flexibility. Okay, this class, and you can add more items. You can also remove items from the from this container. Okay, basically this is a kind of container or collection. Okay, from the collection Java. Later on, we will learn more. Okay, but anyway, so array list. So it's a class. Okay, it's a class, and so it has some constructor. So can be empty. Then the empty list is that the initial capacity is 10. Okay, or you can specify the initial capacity. Then you can call this array list. And this one later on we will learn. And then you can add items. So when you call this add method, it's add at the back of the array list. Okay. Or you can specify where you want to add. Okay, where you want to add. You can also call add all. Okay, this is another array list. Then you can add to the end of the existing one. You can also specify where you want to add. And it also provide the clone. And over here says the clone is a shallow copy, okay, not a deep copy one, be careful. And it can also check if certain item is within this array list. You can also see over here to just take object because this is more general, etc. Then you can plug in whatever, because in Java, all class, so object is a superclass of all of the other classes. So if you use object, then it can take all sorts of class. So it's more flexible. And you can also get the certain item. So this is like indexing operation, okay? And you can also find the object's index, okay? And when you plug in over here, here is object. When you plug in with a different, then this is what? This is polymorphism. If you plug in some subclass, is it? That's a polymorphism. And some of the like iterator later on we will discuss, okay? But like last index, so you may have multiple occurrence of some object, then it will be the last occurrence. And you can also remove, you can remove from the specified location, or you can remove the specified object, okay? And you can also do replace. You can also reassign items. You can also do sorting, okay? You can also convert array list to array. And there are these two are two different to array method. And this is what we call, this is overloaded method. Because the two have the same name, but different signature. Okay. So these are the overloaded method. So we know this array list. Then next, let's take a look at an example. Okay. This example from our website, it's chapter 11 test array. Okay. So let's take a look. This example is also quite straightforward. So in order to use array list, you need to do the import this package. It's a package, okay. So array list. So you need to import this array list class. And over here, later on, we're also going to use circle. And circle is from Java FX package. Then scene package shape, and then the circle, okay. So we need to import the respective package we want to use. So to use array list, whenever you want to use array list, you need to use this angle brackets and plug in the type. And the type must be reference type. So if you want to have an integer array list, then you need to do what? Array list. You need to plug in with this integer. Okay, then you can do new, then array list. And here is empty. You don't need to repeat. No need to repeat. Okay, it knows from whatever here you defined. You want to parameterize. We call it parameterized with integer. Okay, you cannot, so that's not allowed. Not allowed. So only allow a reference type. Okay, must be reference type. No primitive type. So always keep this in mind. So that's why we need the wrapper class, if you recall, wrapper class. And if you want a character, then you need to do this big character, okay? Or like a double, or like a Boolean. Okay, you need to use all of those wrapper class because it can only take reference time. Okay, so that's the requirement whenever you want to use array list. So anyway, in this case, it's some string. Okay, a number of strings, we call it city list. So initialize by default, it's 10 items. It's a 10 item. And then you can just call the add. So here we add London, Denver, Paris, Miami, Seoul, is it? We can add all of them. And then it also shows that what it contains, is it? Tokyo. And so whenever you add, you can see it's always add what? Add at the back. Is it add at the back? And then you can check the size of this list. So how many items in this list? You can just call the data size. You can also check if certain items, so this is kind of like a search, is it? So in ArrayList, they need to call contains. So basically it's a search. So you want to search if the specified item is in the list, you can call contains. And if you want to know the index of the specific item, is it? So you can call the index of. The index of, then in this case, it will return you 1, is it? You can also check if it is empty, okay? And what the next one try to show is, you can also specify where you want to insert. As here says insert at index, yeah. So it is insert. So this is sub 0, sub 1, and sub 2, is it? So it does insert it at the specified location. You can also remove, is it? So after we call the remove, that item is removed, is it? Removed. And you can also specify where you want to remove, is it? So you want to remove them, is it? So it just shows us how we use a array list, okay? And array list by default, because a toString, is it? toString, so array list has an overridden toString method for objects. So you can also call its toString that will output item 1 by 1. And you can also do the loop. Is it? If you want to do the loop, then you can do you can use like the size and then decrement to get each of the item from in the reverse order in this. And this get is kind of like the indexing operation to retrieve the specific item, okay? So that's regarding for a string array list. We take a look at the example, is it? And it can take any kind of reference type. So you can also plug in a circle, is it? Then in this case, you want to store a number of circles in an array list. So then you can add the first circle, the second circle, is it? And if you want to retrieve the specific one, so what over here, this part, then you get the first item from this array list. First item, so it's the first circle, is it? The first circle, the radius is what? Is 2, is it? So what this list that get? Return you what? Return you a circle object. Is it? Return you. So that's why then next you can use get radius. Get radius is instance method of circle class. So that's how you can directly access its instance method. Okay. And then we can output the area of the circle once you get to radius, is it? Okay, and we can run this example and take a look. Yeah, so it gives you like the list size, you can find it, is it? And after you remove, it is still there or not. And the other, and the circle, the area it also gives you. Okay, so basically, that's regarding the last example in this chapter. Okay, and what next? Let's do a. I cannot share. Let's take let's see where the. Let's take a look of our. It's not showing. Hold on, let me do share screen. Share screen, yeah. Let's take a look at the summary of what we learned in this chapter 11. Okay, so most concepts about inheritance and polymorphism. And the superclass, subclass, we already learned, is it? And our textbook, it gave us an example like a geometric object. So this is superclass. And a superclass also have multiple subclass. So in this case, it has a circle subclass. It also has another subclass, rectangle. Okay, rectangle. And over here, it also shows us in the UML diagram to show the inheritance among different classes. Okay. And superclass, subclass, concept. The constructor we already mentioned, it's not inherited. Okay, you must using the super keyword to invoke explicitly. Okay, if you don't, then it will implicitly invoke the default one, the no arg one. We are automatically, okay, so like over here said, if the super is not explicitly used, the no arg construct will automatically be invoked. So constructor cannot be inherited, but other method, then you can do the override. You can inherit. So keep that in mind. Okay. Keyword super is that you can use it to call, and you can also use it to call method, and also the instance variable. Okay. Constructor chain, yeah. So this concept is like in this case. So in this case, person is a superclass of employee. Is it employee extends person? Is it and then employee? Then we have faculty. So we have 3 levels of inheritance. Is it? And then in main, is it? You call what? You call faculty. You create a faculty. Is it? You create a faculty, and basically what it's going to do is what? It's first going to call employees constructor. And the employees constructor, then it's going to call what? Call the persons. Okay, so you, even though you just call in faculty, but automatically you will get output of the contents from superclasses constructor. Okay, so that's what we call constructor chaining. So even though you just call subclass constructor, but superclass constructor will also be invoked, so that all of the instance variable can get initialized. And you after class, if you want, you can trace that. Okay. Defining subclass, we already know that, and we can also provide the override method. Okay, override method called method overriding. Overriding, so name, both name and the signature are the same. Okay, so nothing changed. Then which version is going to be called? It's called dynamic binding. And here it also shows the difference between overriding and overloading. And the object class, I already said, it's a root class. Okay, so it's that every class in Java is descended from Java language object class. So even though, like in this case, you just write a class circle, but basically it's equivalent to you write as extends object. Okay, it's just we didn't explicitly write it. And the toString, like we said, toString object class has toString. So normally, if you create a class, you want it to be output as whatever format you prefer, then you need to redefine it. You need to override the superclasses. Okay, and the polymorphism is it. So polymorphism, and we already see. So class defines the type. The type defines its subtype, and the supertype we define. And we can also use the circle subtype of geometric, and geometric is supertype of circle, etc. So this kind of concept, then basically, if you recall, in our example, we also discussed, etc. So that method, etc. So that's regarding polymorphism and dynamic binding, etc. So the parameter type is very generic. It's object. That is object. But any subtype can be used. It can be used. So it says this feature is known as polymorphism. So it can take any subtype. Any subtype. So this is polymorphism. And then it calls the toString. The toString. So the toString, then it will be the respective toString. Okay, the respective one toString. So then this is called dynamic binding. Okay, dynamic binding. The respective one is going to be plugged in. Depends on its graduate student or person or object. Then the respective one will be called. Okay, so over here, this toString depends on the subtype. Then it's called dynamic binding. Okay, we also know this concept, and that we are going to learn later. Okay, and object cast. Okay, so in this case, there is no need you do the casting as object, because student is an object. Okay, there is not necessary to do explicit casting. And when the casting is necessary, then this is a supertype. Is it? And here is a subtype. Then you do need a casting. then you must have casting. Okay. And the instance of, yeah. So after you do like a subtype assigned to a supertype, is it? And if you want to check if it is the subtype, you can call the instance of. Okay, so instance of can test whether object is an instance of a class. So a lot of times quite helpful. And the polymorphism, we already saw that. And the equals, we already explained, and the difference between equals and equal reference check. ArrayList, we also discussed the example, okay? And whenever you use ArrayList, make sure you need this angle brackets and plug in with a reference type, okay? And when you do the new, then this one can, it's not mandatory. Of course, you are still allowed to do that, but it's not mandatory anymore. Okay, you can just leave it blank. And the difference between array and ArrayList, we already see is that for array, the size is fixed. And if you want to reference specific item, you need to do the index, is it? And for the ArrayList, then you need to call the respective get and set. So get kind of like that index, and the set kind of like you do the assignment. Okay, so this two. But ArrayList has more methods. It can do add, can do remove, can also clear. Okay. And for ArrayList, we can also convert it back and forth between ArrayList and array, is it? So here we have an array for color, is it? And if you want to store it in an ArrayList, then you can just directly plug in it. But you call arrays dot as a list. And this arrays is also a class. Okay, later on in our collection library, we will learn. But anyways, over here, you can convert this. This is an array, and you're going to convert it to a list. So then you can plug in, because it doesn't directly take in array, it takes a collection. So it must be some kind of container, okay? And you can also convert the ArrayList to array, okay, to array. So here is array, is it? And this list is an ArrayList, and you can also convert it and let all the color red, green, blue store in this array. This array, then you call the ArrayList dot to string, okay, do the conversion. For ArrayList, you can also, if you want to find the maximum value and the minimum value, we can also call the max function and the minimum function from Java collection, okay? Then you pass in an ArrayList. So here it gave us an example, okay? So plug in. So over here, so this is the max method. Then you plug in an ArrayList, is it? And this is array. So if you want to find the maximum item from an array, you first can convert it to an ArrayList. Then you plug into this max method. Same thing for the minimum. The minimum, maximum, we know that. And for ArrayList, it also allows us to do the shuffle, okay? So rearrange the order of an array if you want. Then you can call this collection.shuffle method, and you plug in an ArrayList. Okay, ArrayList in Java is quite helpful. Okay, can be used a lot. And for the stack, later on, we will learn. And the protected modifier we also discussed. And here is about the comparison for the accessibility, the visibility, okay, between public, protected, private, and the default. Default is you don't specify, you leave it alone, is it? And the first column is about the same class, of course, everyone allows. And the second one, same package. Same package, be careful, private is exclude. Only public, protected, and default, they are allowed in the same package, okay? And then the next one is from some subclass. Subclass only public and protected, even for the same package, no, okay? They are not allowed for the default, if you define as default. And of course, from different package, then public is everyone can access, okay? So here just give us a different accessibility level, the visibility, and here to give us an example, okay? We can take a look. So here you have two different package. So package 1, here is package 2, is it? So this first package, this is the first package. It has 3 classes, 1, 2, and 3 classes, is it? And this C3 extends C1, so it's a subclass. Is it a subclass? So let's see. So here you have public, protected. This is default one. This is private, is it? Then let's see. So this C2 is in the same package. Same package, then it can access X, public, definitely, protected, definitely, default, definitely, but cannot access private. So this not accessible, is it? And this one also in the same package, but it's also subclass. So it's accessible of that, but cannot access private, okay? And then for the second package, this is a second package. Second package, and this class, it also inherited C1, is it? Inherited C1, definitely X, it can access, and Y is protected, but in different package, so it's still allowed. But because it's a subclass. But for default one, it's not allowed. The private one, not allowed, okay? And for the other one, so this has nothing to do with the other package and other class, is it? Then it only access the public. All of the other protected, default, and the private, all not allowed to access. So here is about visibility, okay, that's a modifier. The subclass cannot weaken the accessibility, okay? And it said the concept is subclass can override protected method and change its visibility to public. That's fine, okay? But it's a subclass cannot weaken the accessibility of method defined in superclass. So if in superclass it's public, then in subclass it must also be public. You cannot then change it to private. That's not allowed, okay? And it says modifier used on classes and the members, okay? Except it says the final, there is another modifier called final. And we already know if a class, you define it as a final, then that class cannot be inherited. So it's not allowed to be created with a subclass, okay? And a final, if a variable is a final one, that just represent a constant. Okay, constant. And be very careful. If a class is defined as a final class, then you cannot extend the class. Okay, so no subclass allowed. So this is a final level of class. And also, if a method is defined as final, then it cannot be overridden by the subclass. Okay, so those are just some, so suppose we don't define as final, but you have a method defined as final, suppose, okay, get x, something like that. Then if you have a subclass, so class submass, suppose you call extends mass, then you cannot. So if you want to also do final, suppose integer x, then you cannot provide like at override. Then you call integer public integer get x. You said override like that. That's not allowed. Okay, you cannot. It's not allowed. So be careful about also the final modifier. Okay, it's also quite helpful. Okay, and I think